All right. Hello, everybody. Welcome in. Thanks for joining us today. We really appreciate you carving a chunk of time out to listen to this information. Before we get started, we're going to start with some just quick housekeeping. So first is a big thank you to all of our sponsors, especially Intel, who's sponsoring today's webinar. So really appreciate everything you do for the community. And then this is a Zoom webinar, so please keep that noted. It is being recorded. If you have any questions, please put it in the chat or in the Q&A section. We will do our best to answer all of your questions in the time that we have today. And last but not least, just a shameless plug for our post-event survey. We really love your feedback. It helps guide what sessions, what webinars we can bring to you in the future. So please fill that out. The information is vital to the community, and two lucky survey participants will be randomly selected to get a $25 Amazon gift card. So that is always helpful, especially in these summer months. But without further ado, Michael, the floor is all yours.
Welcome, everybody. So I wanted to do a couple quick introductions. My name is Mike Simon. I'm the Dell product line manager for the Intel Acceleration technologies, and joining us is also Manya Rostogi from our technical marketing engineering team. So Manya helps us a lot with creating white papers and doing a lot of the more of the technical hands-on piece. So what I want to start with is I'm going to walk through some of what Intel has been doing with their 17 gen servers, and then I'll move on to the Intel Gaudi technologies, which is the highlight of today's presentation of what is Intel doing for AI from around performance, what they're doing in the future. So we're going to cover not only Gaudi3, but 17 gen PowerEdge and also the new Intel AI factory that we announced back in April. So without further ado, moving on to 17 gen servers featuring Xeon 6. So what is the new platform from Intel? So when we look at the different platforms, we have different form factors, 1U, 2U, as is tradition, but a little bit different from how the processors are laid out. We have moved from a metal type setup, gold, bronze, platinum, so on and so forth, to what's called the Intel Xeon E-core and P-core processors with cold aisle support, new features within iDRAC. Those of you not familiar with iDRAC, that's an integrated Dell remote access controller. So that's your remote access. So you don't have to get in the car and drive to the data center. That just gives you complete remote access. And then obviously things that we have kind of have stuck to industry standard firmware, Gen 5 PCI slots, which is faster, bigger, better, faster. That's always the server conversation as we move into new features. But as we look at it, why the change? Why the change from the old metal type processor series to the new version? And it's all about the market needs. This is feedback that we get from customers, feedback that we get from partners is what do we need to change from generation to generation? So looking at the Intel Xeon 6 there's a broader range of compute demands. I think we've all seen that. We're moving into different AI workloads. We're moving into different virtual workloads, high performance compute workloads. We need different levels of performance, but also efficiency, depending on the application that's running in the data center. Sometimes we need a more efficient, more dense processor that consumes less power but gives you a lot more cores to be able to actually get there. And then obviously simplifying development and deployment with a shared hardware and common software stack. And we're seeing that across, doesn't matter where the actual platform is, whether that be a smart PC, an AI enabled laptop, to a precision workstation, to a Xeon type server processor, we need to have a software stack that works across a lot of those platforms. So looking at the two different versions of Xeon 6, so we have Sierra Forest, which is the E series. So the E series stands for the efficient uh, portion of it. Is you're going to get increased core counts, better efficiency, really made for single-threaded applications. Think single-threaded like the calculator on your computer. I know that sounds like the most basic of the applications, but when you have a lot of those little type applications, sometimes you just need a lot of cores and you need it to consume a lot less power. That's where the E series Sierra Forest comes in. When we look at the P series or Granite Rapids, we are looking at what we traditionally see in the majority of data centers: virtualization, VDI. When we're looking at AI, we have a lot of those built in. So when we look at what type of workloads, so this is really where it kind of, I would say, phones home, is where do I need the performance core on the left, the efficiency core on the right, things like micro web services, multi-tenant VMs, DevOps, digital, even things like networking when we're doing any kind of NFV or CDN. But as you get to the left, this is where our traditional architecture sits. This is where performance core really comes into play. So things like generative AI or hyperconverged storage. So any kind of hyperconverged infrastructure, mainstream virtualization, any kind of video distributed analytics, all of those are going to be more of a P core. So we expect more of the P core, but we know that there's a subset of the market that really needs the E core, where they just need a ton of cores for being able to do some of those like DevOps type applications. All right, so let's move into Intel Gaudi. So we do have a poll question. So if we do want to go ahead and throw up the poll. So where does the name Gaudi originate from? Is it a fictional name made up by Intel? That's always possible. We like to do that in the tech world. The Roman god of architecture. It is the surname of a famous architect, Antonio Gaudi from Barcelona, or it originates from the famous mountain range in Italy. We'll just give that a second and then we'll go ahead and jump on it. All right. Pretty good to go on the poll? All right, let's see. Fictional name made by Intel. Nobody thought that? All right, Roman god of architecture. It is not. It is number 3. It's the surname of the famous architect Antonio Gaudi. Those of you who are familiar, who have ever been to Barcelona, the world's tallest cathedral in Barcelona was built by Antonio Gaudi, along with 10 of the most famous architectural standards in Europe. Is a very famous architecture from late 1800s to the early 1900s, which is interesting because he actually had, at the age of 6, he had a debilitating disease that you would never think that he was able to actually do something so magnificent. But that is the kind of the history around Gaudi. When you actually look at the Gaudi chip, it is quite the architectural genius of how they built this, and we'll go through the why behind it. All right, moving on. So, how does Intel Gaudi address enterprise challenges? When we look at GPU architectures in the Gen AI world, it's new. We're only a couple years into it. It's moving at a massively rapid pace of adoption. But one of the biggest portions of it is up until recently, there was only one vendor that was out there. So we need more choice around it. So this addresses that piece of it. So being able to bring choice into the market of having a different vendor. Everybody does something a little bit different between the 3 major vendors that are out there. But the other part is it gets away from the locked-in proprietary software and networking standards. So Gaudi uses Ethernet-based everything. So whether it be chip to chip on the top on the actual board, communicating GPU to GPU, or we call them AI accelerators. But there's also, it's all open standard software protocols. So there's no licensing that goes along with it. You can go and download the AI packages from Intel today. You can deploy them on a laptop. You can deploy them on a server just as a standalone. When you need the bigger horsepower, that's where Gaudi comes in, obviously with the GPU. The next part is the ability to scale while containing those the costs of the infrastructure. So being able to scale from a single node to 4 nodes to 16 nodes, 32 nodes, 64 nodes. We typically go in those the ranges of 8. That's pretty standard infrastructure. But being able to actually scale, but you're scaling across an Ethernet-based network instead of an InfiniBand network. So most of us that have stepped foot in the tech world have at least a basic, if not a very intimate knowledge of what Ethernet protocols are. And at the end of the day, efficiency is a big part of this conversation. I will say that these boxes consume a lot of power, but it's getting the best performance per watt when you're looking at this GPU architecture that is really kind of changing the name of the game. Is how do you get the best performance per watt, per rack unit, per rack aisle, and that's where a lot of the architecture has come into play. So where are the fits for Gaudi3 Accelerator? And the reason that we like to highlight this is obviously it's focused for on-prem deployment, like most big GPU platforms, but it is really focused around GenAI models, so large language models, multimodal models, RAG models. When we're looking at those type of applications, that's really where Gaudi is positioned. So deployment size, ranging from a single system all the way up to large scale clusters. It could do anything in between. If you're just looking to do a small, chatbot or digital twin on site, perfect fit for it. If you're looking to scale, where you're doing something like a very large, Chat GPT type deployment, also scales up to that. But where you are looking for something that is Ethernet based, more simplistic on a network standard, this is a perfect solution for it. And we see a lot of people looking at the open source software stack. So things like PyTorch, DeepSpeed, anything that's open and available to the public without advanced licensing or advanced complexity. And then, of course, shorter lead times to be able to actually get boxes into the clusters. So a little snapshot of the actual technical portion of it, or what kind of features does it have? And it's different than some of the other vendors that we've seen on the market. Is we have some big tensor processor cores, 5th gen, 8 matrix math engines. That seems like a very small number until you look at the actual architecture of it. There's 8 of them on each GPU. You have 8 GPUs per box. We'll look at that on the next slide. There's 8 of them, but they're huge. They're massive compared to the other architectures that are out there, allowing you to ingest data and egress data at a much higher volume, which helps with the efficiency of what the GPU can do. And then when you look at the memory, 128 gigs of high bandwidth memory, 96 megs of cache. Memory is king in this world. That is where everything sits. That is where everything is processed. And then we have, of course, the 24 by 200 gig Ethernet ports. When I say that, you can kind of see it on the picture on the right, but all those little green portions on the side where it says Intel Gaudi, each one of those is a Ethernet connection that allows GPU to GPU connection, and then also external connection. So when I say external connection, this is a picture of effectively what the XE9680 looks like. But on the back of this box, and we'll look at it in just a second, it has 6 800 gig Rocky ports built into the box. Why is that important? Is this is a different architecture than what we've seen in anywhere in the market until the Gaudi product came out. Is normally you'd have to populate all those PCI slots in the front with a bunch of InfiniBand cards or high-speed Ethernet cards, whereas this has it all built into the back of the box. So on the front of the box, you just need to populate out your connections out to your storage network or your control plane network, or if you have multiple storage networks, that's where you'd add those PCI cards like you'd do on a regular server. But you don't have to populate out all those cards. Overall, from a Dell PowerEdge standpoint, this follows a lot of our pretty standard configuration protocols. So it uses two 5th gen Xeon procs. It is 6U, it is air cooled, so it is not liquid cooled, which helps with complexity in the data center. Liquid cooling is coming. We are moving to a very dense type standard, but still at an air cooled up to the 35 C ambient. And but it does require a 1200 millimeter rack. These are big. They weigh anywhere between 298 and I think 349 pounds. So they're a big unit, but that's where efficiency comes into play. If you need a lot of power, you want it to be as efficient as possible. And then you have 8 NVMe drives in the front. If you're doing any kind of local large language model and you want to store your data locally on the box, you're able to do that with a high-speed NVMe type drive. Where it's actually targeted is from AI, ML, DL training. Talked a little bit about this, but this is really the target market for it. One of the neat things about it, it does have video decoders built in to the hardware for more image ingestion. So if you're doing any kind of imaging or 3D imaging, Gaudi is a very good product for that. So looking at it from a scalable, I talked about this a little bit before, all the way from one node, when you get up into your 64, 512, or even in your 1024, is bigger the cluster, the better the performance. Obviously, you're getting lower latency, faster times to train, larger model sizes. This is when we're getting into those real big areas, but it's not just made for the big areas. If we're just doing it on a small scale, we could do it all the way down from a single node. We see a lot of 4-node clusters, 4, 8, and 16 node are pretty popular in the enterprise space until we get into, if you're a cloud service provider, getting up into those big 512 plus nodes. So we get this question a lot is, I'm looking at it. I want to try it. I want to see what I can do with it before I buy it. So Intel has what's called their Tiber Developer Cloud, or Intel Dev Cloud, is you're able to actually go in and utilize Gaudi3 units and utilize that in a cloud type setting to launch a model. A lot of the models are already loaded in there. You can load your own models and be able to actually start testing that. Outside of just Intel, IBM has also made a significant amount of investment with Gaudi3, where they're offering the ability to do things like VPC or virtual servers, which is more of like a VLLM. Watson X, I think most of us are probably familiar with that term, is as either as software as a service or as software in a private data center. But being able to do different deployable architectures, and we're deploying it across different sites around the world. So Dallas, Frankfurt, and Washington D.C., and a lot of that's already available and already built up. So you have a couple different options to go and try it before you buy it, if you will, to be able to actually try the different cloud options with the Intel Gaudi3 platform. All right, moving on. Dell AI Factory. Those of you who are not familiar, we have been building out the AI Factory strategy for quite some time. We've had a couple previous architectures. We have AI Factory with Intel is now readily available. But to give you a snapshot of what the actual portfolio looks like. So we have the version with NVIDIA. So NVIDIA has a couple of their uh, NVAIE, so NVIDIA for enterprise configs. And then you have portfolios with AMD and then portfolios with Intel. And you'll see those across those three, it's an open software stack. So there's a couple that are proprietary, but everybody has an open software stack. And we're going to be focusing obviously on the Intel side today of what that actually looks like and what this actually is. So I'm going to go through what is an AI factory. But first, there's the challenges with implementing AI. I think this is where everybody gets a little stuck, right? Finding your data when you're looking at your internal data should be faster. It should be easier to use. You don't want to wait on IT. You want everything faster. And initial use cases in production, but not really seeing the expected value. It's like having a chat bot, but when you ask the chat bot a question, it doesn't give you the right answer. Is you're not really seeing that value of it. And then obviously reaching scale, but the costs are growing. So how do we enable that? Is we utilize different use cases. Dedicating infrastructure is a way, not a detour. So how do we get to that point? And this is really where a lot of our partnerships come into play, is being able to, we could provide the infrastructure all day long, but we need the software to be able to actually be able to choose the right model, choose the right application, choose the right automation, and beginning with the final use case in mind, actually be able to get there. And that's really what the AI factory is built around. So when we look at what is an AI factory, when we say that, that sounds like kind of a generic term, but we've put a lot of creation into this, a lot of dedication, a lot of engineering resources, massive amount of engineering resources. So of course you start with your use case. You have to have an idea. What do you really want at the end of the day? Do I want a digital assistant? Do I want a talking head telling me what to do? When I ask it a question, do I want digital twin? Do I want something like my own version of Chat GPT? Or do I want to get down into a different use case? Things like synthetic data generation, code generation, automating documents. There's a lot of different use cases for it. Computer vision is a big one. If I have a lot of cameras and monitoring my agricultural fields to see what crops are good, what crops are bad, are we dealing with pest problems? We see it there. We see it in brewery companies. We see it in all kinds of different industries. A lot of different use cases where what would take somebody that would be doing a very, benign job and automating that through some kind of an AI type location. And of course, data fuels the beast, right? It is fuels all AI. It's a data monster, is what we call it. Is constantly consuming data as much as you can give it, and where that data comes from is obviously your core data center. But think of cloud applications, so cloud native applications that are out there. They're born in the cloud, they stay in the cloud, they never come out of the cloud, but they do produce a massive amount of data. We could see that daily on any app on your phone. But also at the edge. So edge devices, whether they be cameras that are recording something, or they could be different sensors on shelves. So you see that in the retail industry. A lot of edge devices that are out there, a lot of edge applications. Everything is producing data, and you have to do something with that data. If you're not doing something with that data, then it's just sitting there and consuming space, and it's not giving you anything back. But at the end of the day, obviously the infrastructure, that's a little bit of what we're talking about today. That's what Dell does really well from a compute storage. Obviously we need data protection, we need networking. And then moving up into the ecosystem is what models, what tools, what agents, and then the services that Dell could wrap around that. So how do you help me get off the ground? Whether that be a physical hardware deployment, whether that be different consulting services, whether that be the ability to deploy a model, um, help me with my data, and or if it's just a flat out strategy, help me lay out what I want to do going forward, and that all leads to the final outcome. Right? My first improving productivity was at my final goal. My reducing costs by saving on business processes, accelerating time to revenue. So we utilize it here at Dell for virtually everything from a sales support chat type bot. So if I want to ask it what part number for this product because this customer's server broke, I'm able to do that on my cell phone. I can do it on an app on my phone, or I could do it on an app internally. We're able to utilize that to speed up the process to get an answer for whatever question that may come out. Or it's something that's accelerating innovation. We see it a lot in the science community. We see it a lot in the gas and oil industry. Any kind of the geothermals is you're trying to innovate as fast as you possibly can to be able to actually get a good outcome. All right, so what's new with the AI platform? 200 gig storage networking. We have now come out with a new 200 gig storage platform, an all flash platform, and the industry is moving towards a 200 gig storage. So we've already integrated that into the AI factory to kind of get ahead of the curve. And then this is the first AI factory with Gaudi3, so the one featuring Intel. So talked a little bit about that, and Manuel talked a lot more about it. And then a common pre-validated open source software stack. So we utilize what's called Omnia, which I'll touch on a little bit more. But this is going to give you all your ML ops, your models, and effectively the ability to bring up an entire stack and tear down an entire stack. So if you're doing something as GPU as a service, or you're moving from generation to generation, you need to have a tool that allows you to do that quickly, and it's not an overcomplicated task. So one of the things that we did a small, medium, large, or what we call T-shirt descriptions. Is that this is a very busy slide, but I'm gonna oversimplify it. Is when you look at it from where you want to start, is if you just need a couple units and you want to have the ability to do a rack scale, is you have two of the 9680s, which is 16 GPUs. Then you have the switching that goes along with it, which is the power switching. You have the storage, and then you have the software that comes along. And then you could pick your services of what you need help with and what you're able to actually do on your own. So if you need custom rack integration, we can do that. If you need residency support, we can do that as well. So that would be actually sending a person out to actually help with it. If you need something that's a little bit larger, and then we help. We have an entire team that will help actually size where the environment sits. And the good part is it's flexible. You could add or subtract things. You already have your own storage units. All your data is already consolidated. That's great. We adjust the configuration based off of what the environment requires. When we get into the very large, this is a lot of times where we see kind of a greenfield type deployment. When we get up into that, 128 GPUs or 16 of the actual servers, a little bit more networking, and then you can see it's more of a 5-rack type deployment. Why we did this is we see that it's common that it's hard to figure out where to start, and this gives a good starting point. I would say that it's a great starting point. Is it always a cookie cutter? We just pick one and go ahead and deploy it, and that's usually not the case, right? We pick one, we start there, we adjust based off of the environment, and then we actually get it into the correct sizing for the application. So looking at it, the why, right? we're looking at it for performance. You want scale, you want flexibility, be able to choose which silicon, which Ethernet, which software, and how you want to implement it. But being able to actually perform to get the best total cost of ownership. So we look at the actual software stack itself. So we have the full software stack from either your RAG frameworks all the way at the top, infrastructure at the bottom. So you have the XE9680. You choose your silicon provider. You choose your operating system. Several that are supported. And then you move up into the infrastructure management. We utilize Omnia as the main one that I mentioned before. And then you'll see most of the big models and ML ops tools that are out there in the market. So a lot of support, and this slide changes, I would say monthly, if not weekly, if not daily. But who are you using? Are you using a virtual LLM or VLLM? Hugging Face is obviously one of the big names that are out there. And then when you get up into your ML ops tool, PyTorch is one of the biggest ones that is utilized in the market. But there's a lot of other ones that are out there. Things like DeepSpeed has been wildly popular, but we've also seen things like Synky or Intel's OpenVINO if you're utilizing that type of tool set. The point of this entire slide is we have a wide range of support within the Dell Technologies portfolio and the AI factory. So how does Intel differentiate? So this is high performance with a reduced TCO. So it does have, the Gaudi product does have a pretty significant lower cost. Better price per performance. There's really no software costs or lock-in with the open source stack. So that is a pretty big advantage, is we don't have a proprietary set of software. When we look at scalable, scales from a storage side, there's no InfiniBand, it's all Ethernet. It's built in, so it is very scalable. It's a very high speed Ethernet. 800 gig is a new protocol for a lot of us, but being able to push data across that network is highly beneficial. And then flexibility with that open source stack. When I say flexibility, think I can move a workload from just a Xeon based system to a Gaudi based system. If I need to move it to another vendor based system, being open source, it's pretty flexible to be able to actually move things around. I know we always say 3 lines of code. It's not just 3 lines of code. There's obviously some tuning work that needs to go along with that, but for the most part that gets you about 90% there. But that allows you to customize and move around and really have a very versatile type platform. So really where we're looking at it is all about choice, efficiency, open ecosystem. I know I say a lot of the different areas where we see a lot of the targets, obviously cloud service providers, healthcare, finance, research and universities looking at this intensely. So, it's really, when we look at it, this is our AI architects, data scientists, CIOs are the ones that have a vested interest in it. All right, so a quick snapshot of just what the hardware looks like. So when we're looking at the actual hardware, this one side, the 9680, which has this big universal baseboard that goes into it. And then we utilize what's called the Broadcom, you'll hear it as called Thor in the open market. That's a 200 gig card for the 200 gig networking. And then from the networking, you're going to have everything from a 100 to a 800 gig switching. And then our PowerScale is a new 200 gig flash storage platform that would actually be utilized if we're looking at the overall AI factory. Then from a networking design, you can see it's a fairly simplistic network compared to what we've seen in the past. You have your XE9680s kind of in the middle that are highlighted there. You have your 800 gig that's connecting those as its own what we call the accelerator fabric, or some people call it a GPU fabric. Obviously, you have your management network to the right, and then you have your storage and Kubernetes or control plane type network that's going to be connected out to 100 gig. So this gives you the storage and access network to the top left, your accelerator network on the bottom, and then your out-of-band network or your management network that is going to be connected out to a 100 gig. I know this looks like a very simplistic view. Obviously, once you scale, it gets a little bit more complex. But from an overall just visual standpoint, high level, that's what we look at from a standpoint. Just want to give you a quick view of the front and the back of the chassis. You can see on the back of the chassis, you have the 800 gig ports built into the bottom. Obviously, you have some of the physical views, a BOS card, which is a boot optimized storage system. That's where your operating system sits in the back of the chassis. Front, you have your PCI cards, you have your hard drives on the very top, but it pretty simplistic from an actual configuration standpoint. I'm gonna pass on this one because I want to make sure that Anya has her time. But from an Omnia standpoint, it's all Ansible based. This is basically we have a support cost around it, but not a software cost around it. But this allows you to do things like bring up a stack, bring down a stack. But it does things like downloads, installs open source, free use software for cluster management. So you can see all the features that are on there. So you have drivers, runtime libraries, frameworks, applications and performance. And then you're able to manage the systems through, typically it's Kubernetes, but you could also use Slurm. And then being able to, grow those clusters as needed. So typically these clusters grow as they progress. And looking at the runtime software environment, so pre-validated software, I already touched on this, so I'm not going to spend a lot of time on here. But we have the PowerEdge iDRAC at the very bottom. Again, that's the integrated remote access controller. You have your workload manager, which is going to be Kubernetes. And then you move up to the Gaudi software platform, and then your different ML tools, and then your tools and models. So as you move up the different stack, and I'm going to let Manya touch on a lot of that because it's going to be a lot of what she touches on there. And then a quick snapshot of what the Gaudi software suite actually looks like. So it uses a PyTorch framework. So it provides, obviously, those machine learning kernel supports. And there's a lot of pre-built images and different libraries that you can go and get from Intel's support page. But this is going to give you the ability to actually deploy it. When we have walked through some of these deployments, I've seen them as quick as an hour to actually get one up and running. And that is from power on the system to getting the Gaudi software actually fully prepped and ready for whatever framework that you want to put on top of it, or whatever model you want to put on top of it. So pretty quick. There's been a lot of development from Gaudi 2 to Gaudi 3 to be able to actually get to that ease of deployment. Perfect. And with that, I will hand it over to Manya. Go ahead and
thank you, Michael.
Control.
Thank you.
You were in control. Appreciate everybody.
Awesome. That was really insightful. Learned a lot from those slides about Gaudi introduction. So hi, everyone. My name is Manya Rastogi, and I work as a technical marketing engineer at Dell. And like Michael mentioned in the introduction, so part of our team is to get the hardware, run performance benchmarking, and we do that in partnership with Intel engineers. We can also go to third parties and develop white papers, demos, and different kind of collateral. So there's tons of links that I can share with you. But what we're going to cover today, just kind of connecting with the whole webinar so far, based on what Michael presented. We are going to look through some challenges that are going on, and I'll once again go over the architecture highlights for Gaudi in some key parts, and then we'll focus on performance and look at the agentic RAG. And towards the end, I'll also talk about like an API endpoint thing, which is the latest and greatest that we have, a new offering. So we'll talk about that. Okay, so to start with, I'll just mention some key challenges based on like what we are trying to solve on the performance and different data sets that I'll share with you today, why we are doing that. So you are aware, right? Like the AI is growing, evolving at a very, very fast pace. And that leads to three key challenges that at least what we are observing right now. First is the AI workload efficiency. So how can you optimize those resources on either CPU or on GPU and the whole infrastructure without you compromise on the power and performance? And there is some data to back that up from Forrester. 48% companies are struggling to optimize those resources. And even once you do that, how do you scale? Like with the model size increasing, the parameter size increasing every day, Llama 2 to Llama 4, how do you scale that? And then also the ease of use for the performance. I have answered some questions here on the webinar, which is about the stack, like deploying Kubernetes and not just that, but other stack of software from Hugging Face, different libraries, software. So how do we make that easier, since we know that the whole market is going to be surpassing billions of dollars on AI? And that's something we are going to look into today. So before I do that, I know we saw a lot of hardware images and things on AI a little bit that we saw before, but I just want to quickly jog the memory. I know this audience is smart enough, but to go over it, that CPU, if we start with CPU for AI, how does it position itself? We all know that it's for general purpose computing, and CPUs are excellent at sequential processing as opposed to accelerators and GPUs, which are specifically meant for the parallel processing. And when on the right side, you see data types. So, the data types that are supported on CPU today are Int8, BF16, FP16. And why is that important? Because there is a relationship between the precision and speed and accuracy of that. If you look at the chart below, and that's very general observation, nothing to do with um, which can be optimized based on software. But if it's a shorter bit set, then it will be faster, might not be that accurate. But if you need like training larger models, it's probably better to have that higher data set with longer bits up to FP32 so that it can give you more accuracy. Now, why am I mentioning all that? So we saw the CPU evolution that has been going on with Intel, and Intel has been working hard to make the CPUs best for AI and more energy efficient and more best suited for compute as well. And it has a modular architecture right now. So what you see on the right side is that the chiplet architecture, which is being offered right now, has scalar engines, vector engine, matrix engines. And all of that we offer today with PowerEdge server, this chipset, like the latest Intel Gen 6, Intel Xeon 6 Gen that is being offered today, comes with these engines. And memory is the key, like we have been seeing for AI. So we do offer a lot of DIMMs, which support it to 8 TB max on the PowerEdge, and also like Gen 5 PCIes to make it faster with the Dell servers. So again, just a quick overview of why like these AMX, the advanced matrix extension, or AVX is important. And because of these chip, that is the CPU chip, offers these features. So on the left side, you see we like scalar is a number, then there are rows, which is vector, and then matrix, which is rows and columns, and then tensor is a 3D matrix. And that is important because anything in terms of GenAI is going to be converted vectorized. These words or tokens are vectorized, and then a lot of mathematical calculation is done that is used for building applications like chatbot or any agentic AI RAG demos and all of that stuff. So we have AMX called as Advanced Matrix Extension, which is basically it's using a tile architecture. So it has 2D registers, which stores the matrices, and then you can multiply them and store that chunk of data. which is unique feature compared to like other CPUs, and again shows the leadership from Intel on the built-in acceleration that they offer today itself on the chip itself. The AVX has been there for some time, again, helps with the calculation for the faster AI workloads. So since we have seen that, I do have a polling question just after this, which is around, okay, so which feature of Intel's built-in AI acceleration do you find most beneficial for AI and ML applications? And I think I practically gave away the answer for that. So first is the AMX, the Advanced Matrix Extension, or is it Intel Advanced AI or NumPy? It's gonna be an easy one because we just learned about it. And let's see. It looks like we have the answers. And yes, the 75% people got it correctly. It is the Advanced Matrix Extension. That is the separate, like the latest feature, which is being offered by like, from 5th generation of Intel CPU. And so yeah, that's correct. And good job on that. So because we saw all this right now, right? Like, how does these features help? Like, just don't take, my word for it or the data that we or like, these statements, but we actually did some testing in the lab. And what I'm showing here is a RAG workflow with just as the on-5th CPU, which was, it's optimized. It's running with OpenVINO. I saw a question earlier in the webinar about OpenVINO. So we have used some of those features like the neural network compression framework, VNNI, and quantization from OpenVINO that it can do to BF16 to int8. And the purpose is not like, to intimidate you with the RAG workflow diagram here, but to showcase that all of this was done only on the CPU itself. So when we talk of scaling, if you have a smaller billion parameter like a Llama 2 that we did here, which was just 7 billion, you can run it on an Intel CPU. And there are papers and links that we can share with you for the entire information. I know we are limited on time, so I'm trying to keep it faster, but those papers have all the information on hardware configuration and much more on the performance. So again, this slide I want to highlight here, from 5th generation to 6th generation. So we have latest offerings on Intel powered R770 servers with the 6th gen CPU. And we did the testing. The graphs here, what they show is that it's even better than the 5th generation. There are more tokens per second that you can get. The time to first token, time per output token is within the range, which is acceptable by the industry today for a CPU AI workload. So again, papers on that you can see. Now, I just wanted to make a hero entry for the Gaudi3 here. So that's why I had the slide. Like we saw earlier on the slide deck that CPU for AI, what's the quick purpose? Again, similar stuff for GPU. These are particularly Accelerator like Gaudi is designed for AI and ML and training and inferencing. And it's because it is so good at parallel processing. Looking at all the math calculations that we saw before, that's why parallel processing is super important. And it also supports like, higher data types, like up to FP32. So, and the scale matters because all of this is super important in processing all the instruction sets simultaneously and tuning the knobs which are required, like different parameters, 70 billion parameters, which are required for training or even in some cases inferencing. So here is the Gaudi3 product line. I've seen some of this before in the earlier slides, but just like key difference that, okay, there are two components. One is the OAM card, which is the OCP, Open Compute Platform Accelerator module. It is offered in the form of a mezzanine card. And together, 8 of them are combined together, and it is offered on the universal baseboard. So when you see in the picture below, which is like from the hardware that we received in our lab, direct from the box, is Gaudi3 that will the whole universal baseboard that will go into the XE9680 server that is being offered by Dell. So these are with the heat sinks on top of the accelerator card, the OAM card, and together they are called the universal baseboard and support like the 8 of them are combined together. And With that, we will have one more poll question just to make sure you understood that what we were talking about. So what is the form factor called that supports 8 Intel Gaudi3 AI accelerators? Is it the OCP accelerator module called the OEM? Or is it called the universal baseboard? Or is it a PCIe config? And I think we just saw that. So it's the UBB baseboard or OEM. Let's see what we can answer for that real quick. And yes, 50% of you, more than that, got it correct. It is, got it incorrect. It is not the OEM. It is the single card, which is the OEM. When 8 of them are combined together, it will be the universal baseboard. So if you ever see wordings like UBB or universal baseboard, that is something on which all 8 of them are, all 8 OEMs are combined together, and that forms the baseboard. So, but coming back to it, like each of that OEM card, the mezzanine card, what is that made up of? So just the architecture highlights here I want to show quickly is that the Gaudi3 accelerator chip, it's made up of 2 identical silicon dies. Okay, and 3 main things to consider here. First is compute. It has 64 tensor processor cores, 8 matrix math engines. So when we talk about 8 matrix math engines, we saw why matrix calculation is super important, because especially for GenAI use cases, all the words are converted to vectors, which are then used for which rows and columns used for calculation. So it can do 64K parallel operations together. Again, memory is super important. It supports 8 HBM high bandwidth memory, 2E devices, which is total of 128 gig capacity. And again, it is important because batch sizes are increasing. It's important for speed up for AI workloads, how they are connected together, and how fast you can get the tokens per second out of it. And then last but not the least, networking. And I know Michael had some good slides to show you of the whole switches and connections together, but just to show you here that the 8 accelerators, the UBB, all cards on that are connected together. 3 connections from each one of them go out and provide 200 gig for the scale out. And if you see, the important line here is that 8 of these with 3 of those lines of 200 gig gives the 4.8 bandwidth, which is coming out from the OSFP ports, but there are 6 OSFP ports, not 8. That comes out of the XE9680 servers, which are again connected to the switches like Z9864F, and you can connect multiple multi-nodes for deploying larger workloads. So now we know about the architecture of it. And again, I'm not just gonna go quickly over this. You saw the slide from Michael. This is the actual offering with everything inside it. Intel CPU, Intel Gaudi3 GPU that can do tons of work, which again, we tested the server and tried to do the inferencing with VLLM model serving. And on the left side, you can see a quick diagram for all the open API architecture that we have used. It used the Gaudi software, Docker containers, PyTorch, VLLM, and then Llama 3.1 70 billion workload model that we tested on it. So we've tested both 8 billion and 70 billion, and the tokens per second is pretty impressive as compared with other GPUs, and which shows that it will be excellent for to scale and deploy different kind of workloads that you can do with it. And not just the inferencing, but we also did the fine tuning, the training, because again, it's Gaudi3, and you can scale up, deploy larger models. So I'm not showing the graph here for the 8 billion, but for the 70 billion Llama 3.3, and it can reach up to around 9,000 tokens per second that can be trained for a batch size of 8. And it takes longer than for the smaller models, but yes, it shows scalability again, that it can be used with AI agents, and it does not incur a lot of infrastructure costs. And on the left side, there are all the architecture diagrams. Again, these are papers which are published, so we will share the links with you all that you can go and read all the paper, but all the models that are deployed on the stack to do this entire exercise. With respect to time, I'll keep it going. And this is one more of the RAG application that we deployed. We had this demo at the Supercompute event last year, around November timeframe. So this is a proof of life performance that, it's not just the testing and performance that we have, it actually can run the agentic RAG. This was a very interesting use case where we tried to have the customer support by an internet service provider. Like no one likes talking and waiting for a long hold time to them. So why not just automate that process? And this is what we demoed on the Gaudi3 with XE9680. It has with everything here, agents like CRM databases, speech models. So it was a multimodal, not just like speech to text. So that is what it can do. So it shows all different capabilities which are possible today. And then last but not the least, I did wanted to tease out about the API endpoint inference. So I know all of us are so much worried about like, okay, what does the stack is built up of, whether it's Kubernetes, Optimum Habana, Gaudi software, Synapse software, and then on top of that, PyTorch, Hugging Face, LangChain. How, instead of that, what we are trying to solve, Intel is trying to solve, it's a unique solution and it's really powerful. How about combining all that software stack, providing you a downloadable link that you can download once you have the hardware, or if it's in the cloud, and you can just check just test the inference performance. So just to make like this is the big game for the ease of use, what Intel is doing with Intel AI for enterprise inference. It is offered right now. We can do it. All the software is provided as to an API endpoint, and I have a quick just like a 2-second GIF to show you. So this is an example whether you have it Intel Gaudi 3 on premise, or if it's on cloud, or it's Intel Xeon, not just a GPU, but CPU, or whether you have any other architecture like NVIDIA H100 GPU. Everything is possible to run inference on the box and without any major code write-up. You don't have to change anything. It's an API call, the whole stack exists, and this is really game changing for deploying all that. So with that, I know we are just 2 minutes from the time. I'd like to thank you all for attending this webinar. And if you have any questions, happy to answer right now, or you can connect with me on LinkedIn or reach out. And this is all the assets, the links that I just talked about. Thank you.
Yeah, thank you. I mean, just for everybody on this call, just so you know, all of these links will be sent out in the post-event email, and we'll post them on elevate.com or .org, excuse me. So all of this information will be posted. You will be able to get your hands on it. Don't you worry. But with the time remaining, we do have a couple questions in the chat. So the first comes from Kathy. It's AVX-512 instructions are a parallel vector floating operations. Single precision is 32-bit, double precision is 64. Do we need 32-bit precision for LLM type operation?
No, like you can do either 32-bit precision, like that's what we have been testing with right now, with the floating point. But depends, like if you want to do 64-bit, there are ways of doing it. It's just that it might be slower. It might not be that faster the way that you want to do it. So you can run anything. Yeah, short answer is that you can run anything, but depends on what your output requirement is to make sure that we get what we need. We can optimize it in that way. So that's why our testing is done with 32-bit or 16-bit.
Makes sense. Thank you. And then what looks like is the last question, as we are at time, so we'll answer this one hopefully quickly. NPUs are typically designed for floating point 8-bit or floating point 6-bit. I'm not sure if there's a question there or just shared knowledge. Is there anything you would want to elaborate on that?
No, I guess yeah, that's a good point. Like NPUs are designed for that, and well, if not NPUs, if you just like that's the point of CPUs right now, you can run FP16, FP8 on the CPUs itself as well. So that's it.
Absolutely. Well, thank you both. Thank you everybody for joining us today, staying for the full time. I mean, it looked like everybody stayed the whole time, so that means the information was gold and people really appreciate your time. So Michael, Manya, thank you for being here with us today. We really, really appreciate it. Thank you, Intel. Thank you, Dell. Just a lot of great information. If you have more questions, you can reach out on LinkedIn. You can reach out to member services. We will get your questions answered. But thank you everyone for your time. Any closing thoughts from either of the two of you?
Nope, just appreciate the time. Appreciate everybody's time and listening to us. If you guys have questions, again, feel free to reach out. There's a lot of links that will be going out, and happy to help wherever we can.
Absolutely. Yes. Echo that. Just feel free to reach out if you have any questions, and thank you so much for your time.
Awesome. Thank you, everybody. Have a great rest of your day.
Thanks, everybody.
Thank you.